talk about decay series. I told you in, I think it was the chemical reactions unit, that almost every unit from now on is going to have some sort of graph or curve. You're going to have to analyze. And nuclear is definitely no exception. Now, I don't think that this one's that bad at all. I actually really like decay series. So I'm hoping by the end of this video, you'll really like them too. Now, first of all, this is a graph, so I want to show you what's going on the y and the x-axes. First of all, the y over here is the number of nucleons. You can see that number of nucleons, that's protons and neutrons, that's our mass number. Whereas down here, we have number of protons, the atomic number. So you can see that these isotopes are actually graphed based on 216, 216, 84, 84, based on locations. It's actually graphed based on their mass number and atomic numbers. So that's really cool. I normally, when you guys are working on your homework, maybe your test, I almost always have questions that say, does this say TL or TI? One thing that you can do is look, 81, 81, or if you can't see these numbers very well, you can see them down here. Look it up on your periodic table. So don't forget that they are actually graphed. So if you can't read something, the graph's going to help you know what it is. So before we dive into what you're actually going to have to do on this graph, let's start looking through some things and seeing what's going on. First of all, every isotope that starts a reaction, so this is actually our ultimate one that's starting, is called the parent isotope. So thorium-232 is our parent isotope. Then, as we come down, every time it goes through a reaction, which every time we see one of these arrows, that is a natural occurring decay to make the isotope become more stable. So this one is more stable than this one. And as it comes down, now it's become this. This is the daughter isotope. Now, in this whole decay series, we only have 2 nuclides that are actually stable entirely. All of the nuclides listed on this decay series are radioactive except for 2. So where are our stable isotopes? Yeah, it's these right here. And how do I know? Because they don't have any more arrows coming out of them. The arrows refers to a nuclear reaction. Therefore, if it's naturally going through that nuclear reaction, it is not stable. It's not stable. So what I'm going to do now is I'm going to show you what the arrows actually mean and what the reactions are that involve those arrows. So I'm going to start with radon-220 right here. And we're going to write out the reaction to go from radon-220 to polonium-216. So, radon-220 and atomic number 86 is going to turn into polonium-216, atomic number 84. Cool. And we do have a second part. We're going to have to figure out what that is. And this is just simple balancing nuclear reactions. 220 to 216. This side needs to be 220 as well. So we need a 4 on top. 86 on this side. That means this side needs to be 86. So we need a 2. What is that? Yes, that's an alpha particle. He. It would be also okay if you wrote the little fishy, but that's not as common. He is usually what we see. So that means every time we see a diagonal arrow, it is actually alpha decay, alpha emission. Oops. Now, you can either memorize that, or you can, every time, if you don't want to memorize, you can just write it out and you can see, oh, it's a difference between 4 on the top and 2 on the bottom. That's definitely alpha decay or alpha emission. Let's look and see what this reaction would be. So if you're going from, if you're going to the right, so we're going to do this one right now. Every time you get from one box to another, that is a nuclear reaction. So let's do from bismuth to polonium. Bismuth 212 to polonium-212. So bismuth, 212, and 83, to polonium, 212, to 84. Okay, let's see what we're going to need. 212, 212, so it's going to be a 0 on the top. 83, that means this side needs to be 83, so we need a -1 on the bottom. That is a beta particle. You could also write electron, because a beta particle is an emitted electron. That's the definition of a beta, an electron emitted from a nuclear reaction. So every time we see an arrow going to the right, that's going to be beta emission or beta decay. The last thing that I might ask of you, so I might ask for an individual reaction, but the last thing I might ask is actually for a series. So what I want to do now is I want us to actually write out the decay series for polonium-216, and I want us to write the decay series all the way to thallium-208. So we're going to go from polonium-216 to thallium-208. So first of all, you need to know how many reactions you need to write. We're going to write 1, and this one's going to be in diagonal, so that's alpha. Then we're going to go 2, that's going to be a beta, and then 3, that's diagonal, so that's going to be an alpha. So we're going to write 3 reactions, alpha, beta, then alpha. So let's start with polonium-216, 284, and it's going to turn into first lead-212, and that's 82. Now, to double check your work, you can check your balancing, and we would need a 4 on top and a 2 on the bottom, and there's our alpha emission. So, check, 1 down, 2 more to go. Now we have lead. That's our reactant the second time, so you will actually write 3 different reactions. Now we're starting with lead-212, and it's going to turn into bismuth-212. So that's our next reaction. Lead-212, 82, is going to turn into bismuth-212, 83. Now we look here, we're going to need a 0 on top, -1 on the bottom. There's that beta decay. Again, you can write the little lowercase e here to represent electron as well if you'd rather. So, check, 2 down. Now we've got to turn bismuth-212 into thallium-208. So bismuth, so our product, our daughter isotope of one reaction is going to become the parent isotope of the next. 212, 83 is going to produce thallium-208 and 81. Plus, we need a 4 on top, we need a 2 on the bottom, and there's our alpha emission. So we've done 3 reactions to show the decay series from polonium-216 all the way to thallium-208. And there you have it. That's it. Decay series. I think you guys got this.